Well, good afternoon, everyone. As Jim has already told you, I am here to talk about the work of a consortium that has been working in parallel with the committee that Dr. Stover told us about that was commissioned by ASN. Here are my disclosures. And I might make a comment, though, based on the discussion that we just had about transparency with respect to conflicts of interest for government officials who are Senate confirmed, like I was in the last administration. All of our financial holdings and all of our spouses' financial holdings are made publicly available in a site that's accessible through the internet to everybody. So there is great transparency with respect to financial conflicts of interest for people who hold those kinds of jobs. And our holdings met all of the requirements for conflict of interest in agriculture, food, public health, in my case. But I'm here to talk about scientific integrity, and I'd like to ask you, have you ever been in a situation where you felt that a research project you were working with, a scientific committee that had been convened, that work was somehow compromised? And you ask yourself the question, should you say something about it? And if you did feel that way, did you have a mechanism that you could report this situation to? Have you ever felt pressured to publish? Have you ever felt that research that you had conducted that resulted in findings that were considered to be not significant or negative, that it should be published, but you couldn't get it published? And have you received formal training or education about scientific integrity? If you're a student, is that going on right now in your program? And if you are a faculty member or a government scientist, have you received any kind of formal training about scientific integrity? I have found myself in situations of the first kind where I felt like something was compromised. I've also had results that were negative that I couldn't get published. So I think that these issues that relate to aspects of scientific integrity are some things that are actually quite common and that we struggle with on how we deal with them. The Scientific Integrity Consortium that I've been working with over this last year plus defines scientific integrity as the situation when persons adhere to accepted standards, professional values, and practices of the relevant scientific community in which they are working. It recognizes that a subset of issues in scientific integrity relate to research misconduct, or sometimes called research breach. And these are the cases in which fabrication, falsification, plagiarism in proposing, performing, or reviewing research occur, or in reporting research results. A third term that is used and that we have incorporated into the report from our committee is detrimental research practices, sometimes also referred to as questionable research practices. And these are the occasions when researchers commit research misconduct or are engaging in other behavior that clearly damages research and strays from the norms and the appropriate practices of science, again, in their disciplinary areas. And in Canada, the term questionable research practices is used to refer to this situation. So scientific integrity is complex. There are multiple components to it. And in the research atmosphere in which we're working, the globalization, the increasing interdisciplinary nature of the research projects that are ongoing, the fact that we're working in teams, and also all of these new information technologies that we're using present new challenges to scientific integrity. But we believe that we're making progress, and yet that there is still more work to be done. So in the work of the scientific integrity, we started actually with consideration of individual researchers and the fact that they work within and under the supervision of more senior scientists, and also the organizations that are funding their research. When there are disputes that arise or breaches of scientific integrity, institutional leaders are the ones who are going to be making decisions about the outcome of those disputes. And lastly, peer reviewers and journal editors also play key roles in scientific integrity, the overall ecosystem. The consortium that I am reporting to you about was convened by ILSI North America and was hosted by the Government University Industry Research Roundtable at the National Academy of Sciences, Engineering, and Medicine. The participants included 4 US government agencies, 3 Canadian government agencies, 11 different professional societies, 6 universities, and 3 nonprofit scientific organizations. Sarah Olhorst was the primary representative for ASN, but it was, I think, unusual to have as many participants in this consortium discussions who are ASN members as there were, myself included. I started working with the consortium when I was in government and continued over this past year when I returned to Iowa State. So the breadth of the scientific disciplines that was included in these discussions went far beyond ASN, but we were really well represented. The consortium developed 2 overarching principles for fostering scientific integrity and 9 best practices. And what I'm going to do is describe to you those principles and best practices. The first of the overarching principles is to foster a culture of integrity in the scientific process. And the second recognizes that evidence-based policy interests may have legitimate roles to play in influencing aspects of the research process. But those roles should not interfere with scientific integrity. So let's drill down a little bit on those 2 principles. The first, relating to the culture of integrity, recognizes that this has to be fostered by all facets of the scientific community, and that the institutions in which research are conducted actually have very significant roles to play. They must develop policies, procedures, and practices that address scientific integrity, provide for training of personnel, and work continuously to maintain awareness and advocacy for these practices. And the second overarching policy actually addresses that interface between science and policy. Evidence-based policy interests can be government agencies, can be other sponsors of research, foundations, companies, but those sponsors of evidence-based policy research may have legitimate roles to play in influencing that research process. And this principle recognizes that the ultimate use of science in public policy, as well as in decision-making and public opinion, should not affect the content or the conduct of the science. So this, I think, is a very important principle to be included. There are 9 best practices that the consortium has recommended, and the first of these is to require universal training in scientific methods that would cover issues like experimental design, statistical analysis, responsible research practices, and the promotion of research quality. The second best practice is to strengthen scientific integrity oversight and ethics training. And that would include strengthening the institutional capacity for dealing with research priorities, and also endorses the recommendation from a report from the National Academy of Sciences to establish a research integrity advisory board. The third best practice is to encourage reproducibility through transparency. And included under that is moving to open science frameworks, full and transparent reporting of methods, statistics, and results. The fourth best practice is to establish open science as the norm. And that covers moving to sharing all of our data, the tri-agency open access policy, and also there are still some issues that are open for further development and consideration, including things like intellectual property issues. The fifth best practice is to develop tools to teach communication skills that uphold scientific integrity, training scientists to accurately communicate research, and to ensure approval of press releases. Very important that the authors of scholarly papers have a role in their institution's press release when it goes out. The sixth best practice is to strengthen the peer review process. This includes conflict of interest disclosures, use of robust checklists, and increasing the recognition of review activities. The seventh best practice is to encourage publication of unanticipated findings, recommending that we remove publication bias, and also change the terminology that we use rather than negative findings to unanticipated findings. The eighth best practice is to seek harmonization for retraction or correction of papers, standardizing the language and the processes related to retraction and corrections. And the ninth best practice is to design criteria to recognize high standards of scientific integrity, and this would include the development of new metrics to recognize research quality. Going forward, the consortium is considering two follow-on projects. The principles and the best practices that I've described have been written up and submitted to a journal that currently the article is under review. And we are anticipating fairly soon, hoping that it will have received the final approval for publication. And in the meantime, we've begun talking about what might be the next steps that the consortium undertakes, and there are two of these. One is to develop a checklist that could serve multiple purposes. This checklist on scientific integrity could serve as a guide as an investigator is beginning research to the design, conduct, as well as the reporting of that research. And it could also be used as a tool when you are submitting an article for publication for evaluating whether you have, in the conduct of that research, met these various criteria for scientific integrity. That in itself could be a badge that could appear with the article, essentially a stamp of approval that would indicate that the research that was done met these criteria of scientific integrity. So that is one project moving forward. The second one that's under consideration is, I think, a much harder one, and that is from the institutional perspective, the development of metrics to measure scientific integrity. There are also some initial discussions with ASN about potential things that ASN could take on. And included among those things are using the webinars that ASN has had regularly scheduled to strengthen our members' understanding of scientific integrity, including the kinds of principles and best practices that are within the consortium's recommendations. ASN could consider sponsoring webinars that relate to open access and open data and how members can access those for putting the data that is the result of their research, making it publicly accessible. They could hold a webinar on responsible research practices for the field of nutrition, as well as the issue of media training that we've already touched on earlier in the discussions. And a second potential activity would be to develop educational tools to teach communication skills that would also uphold scientific integrity. With respect to next steps for the consortium, we are engaged at this point in a communications campaign. Dr. House did a presentation on the consortium's principles and best practices a couple of weeks ago at the meeting of the Canadian Nutrition Society, and I am here today sharing these results with you all at ASN. We are very much eager to get feedback on these principles and best practices, and have set up a mailbox to receive them. Comments at scienceintconsortium.com. And the consortium, as I said, is going to start exploring the next steps, including the checklist and the development of metrics, and perhaps even broadening the membership of the consortium. So thank you very much for the invitation to be part of this discussion this afternoon. And I'll leave up the mailbox for comments while we take any questions.
Great, thank you very much. We can now open this presentation up for discussion if there are any questions from the audience. I'll get the ball rolling. In terms of the Canadian Nutrition Society has endorsed these. In fact, when our representation on the committee was Andrea Grantham, our executive director, it went through our ethics committee and we endorsed the best practices and policies. And so we are in fact looking for how to implement on behalf of CNS these strategies and best practices. And so looking for tools, looking for options. And so if there are suggestions from the audience from your own experiences, your own research institutions of examples where research integrity specific examples or guidelines or boards that have been set up, feel free to share those with the rest of the group. Yes, Patrick.
Thank you very much. Could I ask a question? Did the group discuss, when you talk about scientific integrity related to study design, which you talked about a little bit, that trade-off between cost and rigor, where some questions, you may not want to make as big as an investment to do things as rigorously as possible, depending on the impact of the question you're asking. But that balance between, how cost can affect that relationship between the question you're asking and how rigorously that question should be pursued.
I don't recall that we specifically addressed that trade-off between cost and rigor. So I think that we did not go into any certainly in-depth discussion. It is an issue, and I can tell you just from a personal standpoint, I have been very much concerned that our nutrition science literature is filled with studies that are underpowered and upon which we are basing a lot of guidance and government policy. So it is a concern. And if you look at the federal funding for nutrition science, under the doubling at NIH, the research domains in biomedical aspects of nutrition that are funded by NIH, the funding for that has increased. But within the funding that's focused on foods and food systems and nutrition for the maintenance of health that falls within USDA's domain, the funding for that kind of research has been decreasing. So a very important part of the resourcing for nutrition science, particularly as it relates to the food aspects of nutrition, is the funding is becoming less available. Yes?
I have a question with respect to one of those 9 points you mentioned. You referred to peer reviewing system and a checklist for how to design, conduct, and report studies. That's mainly in the hands of, the last one is mainly in the hands of the publishers, of the journals. And the peer reviewing process is also something that is in the hand of the journals. So how do you intend to control that whole process?
Well, first of all, I should say that this consortium is not looking to control the research process that's in the domain of any of the scientific societies that were participating in this. And clearly, when I showed you the slide that showed the levels from the individual scientists to the journal and the peer review process, the whole ecosystem that is involved in assuring the integrity of the scientific process, the journals play a very, very key role, and the scientific societies do, in establishing the norms and the standards for evidence and the expectations of what are, from a scientific perspective, appropriate designs for the kind of science that occurs within that disciplinary field. So the consortium is not looking to replace any of those, but rather within the context of different disciplinary areas to say that on this type of checklist, again, to be developed, that for any of the scientific disciplines, the appropriate design, according to the norms of that discipline, would be part of that checklist. So it's not looking to replace the appropriate role of the leadership within that scientific area of research, but simply to say there should be those kinds of scientific appropriate designs, appropriate statistical analysis that would be defined by that disciplinary area.
That's what I understand, but
Yeah.
the point is that the journals usually dictate how you report your study in the specific journal. And that is not always according to the principles that you refer to or that you want to make statements. So you need to have the journals as partners in those checklists, I suppose.
Yeah, most definitely.
Okay, thank you.
Thank you. Last question.
Thank you. Purnima Menon from IFPRI. So just a quick comment on this. Is any of this supposed to replace or supplement existing checklists that very high impact factor journals are already using, like the consort statements and the strobe and checking of clinical trials registries and things like that?
Well, no, I think these provide good examples for how other scientific disciplinary areas and journals could, adopt such approaches. So,
Okay.
I think we're looking for best practices in other domains that could provide a basis, a reference point for the development of this type of checklist.